Hello friends, I am Dr. Lokesh Desrai, and in the previous video we have discussed R square or coefficient of determination, and in this video we are going to discuss adjusted R square. But first we discuss what are the problems associated with R square or what are the main issues which are required to discuss in R square. So first one is practically not relevance. The value of R square always increases when adding any variable in the model. Even irrelevant variables improve it artificially without having any practical relevance. Cannot detect overfitting. The model may look strong but performs poorly in reality. Does not consider model complexity. A model with 2 predictors and 10 predictors may show the similar R square value. Misleading in the research reporting. Researchers may think higher R square leads to better model, but it may just have more variables and lacks model accuracy theoretically and practically both. So that is why these are the main problems which maybe arises in R square. Hence, we are required to use adjusted R square. So why the adjusted R square is better? Gives true explanatory power of your SEM model, penalize unnecessary predictors, useful for model comparison, and prevents overfitting interpretation. Now we discuss how to calculate R square manually. So the formula for adjusted R square equals to 1 minus n minus 1 divided by n minus k plus 1 and multiplied with 1 minus R square, where R square is coefficient of determination, which we have discussed in the previous video, and we also calculated with smart PLS, and n is a sample size. K is number of predictors associated to the endogenous construct. So it means for that endogenous construct to whom we are going to calculate adjusted R square, how many variables or the constructs or predictors are attached to that particular endogenous constructs, that represents by K. So now we see this formula and we put the values in this formula. So in our case, n 149, sample size is 149, and the k equals to 3. It means we are having three constructs: social support, financial well-being, and work-life balance. These three altogether influence happiness in our model, so we are going to calculate the adjusted R square for happiness. So once we put the values in this formula, we can compute the R square value is 0.667, and when we are using smart PLS, so we'll find the same value. So just open the smart PLS and find out its values. So this is our ongoing model in which I have already done the bootstrapping, and you can find the R square value on the on that particular model. And if you click on left hand side under the quality criteria, you can find the adjusted R square value. So R square adjusted values, click on this and you can find 0.666. So we should consider the values which are in the column original sample. So for happiness, this value comes 0.666, and once we compare it with our calculated value, then it is same, almost 0.666. So in this way we can calculate the adjusted R square manually and with the help of smart PLS. So in the smart PLS you can find the adjusted R square values for the happiness, for the construct happiness and the construct life satisfaction. So these values are comes at 0.666 for happiness and 0.281 for life satisfaction. So now how it can be interpreted: the HP life happiness 0.666, after controlling predictors 66.6% variance is still explained by all the three predictors, and for life satisfaction 0.281, it means after adjustment 28.1% variance is explained by happiness for the life satisfaction. Only a very small drop from R square indicates the model is stable. So there are few situations in which the adjusted R square value might be changed. So what are those situations? The first situation is useful predictors added in the model. If we add the useful or relevant predictors in the model, then your adjusted R square value increases. Okay. Now if we added irrelevant predictors, then the adjusted R square value decreases. And if too many predictors are added in the model, then adjusted R square drops noticeably. So the good stable model is that model in which the adjusted R square value is just similar to the r square. Now in our case, the r square value which we discussed in the previous videos, this is for happiness is 0.673 and for life satisfaction is 0.286. And when we compare this r square with the adjusted r square, it comes 0.666. So it is almost same with 0.673, and this is 0.281, which is almost same to the r square value 0.286. So in this way we can say that the adjusted r square and r square, these are almost same. Hence the model's explanatory power is genuine and not artificially inflated. Now you can see in this sample mean, as we already discussed, sample mean is the average of all the r square and average of all the adjusted r square of 5000 samples in the bootstrapping process. So the smart pls gives you the both measures, one based on the original sample and second is based on the bootstrapping mechanism. And you can also find the p-values that is less than 1% level of significance. So we can say that these r square and adjusted r square are statistically significant, and these are the various situations in which the adjusted r square might be changed. So if all the use predictors are useful, then your adjusted R square increases, and if your irrelevant predictors added, then it decreases, and if we had too many predictors in the model, it drops significantly. So the good stable model indicates the value of adjusted r square and r square is almost same. So it is important to note that always support the results of r square with the adjusted r square in your research assignments for the better interpretation and better reflecting the better accuracy of your model. So thank you so much watching for this video. In this video, I hope you understood about the applications of r square and adjusted r square. So kindly subscribe the channel for the next videos in this series. Thank you so much.